Hello 8th graders, here is your review video for the Chapter 3 test. There will be 16 problems on the test, 4 from each of the sections that you see here. Your first section is one-step equations. Most of this is not new for you. There will be some negative numbers. Don't be surprised to see that. And there's one new type that I'm going to show you what I expect you to do here. The first one is not new. We see the variable. We want to do the opposite to get rid of the stuff that's with the variable. Okay, so I want to get this q all by itself on the left-hand side. To do that, I need to do the opposite of what's there. So the opposite of minus 90 would be plus 90. What I do to one side, I have to do the same thing to the other side, or my equation will not be true. When I see opposite operations, those cancel out, and I just have the variable q left on the left-hand side. On the right-hand side, I'm going to add those things together, and I have my solution. I can plug this in to check 109 instead of q minus 90 equals 19. If it equals the same thing that you see, check, you've got it. Now the second problem here is the tricky one I was talking to you about. This is new this year. So I see that I'm subtracting h. Now that's kind of tricky because how do I solve for h if I'm subtracting the h? Well, I would like you to treat each term as its own plus or minus problem. So if we look here, we've got a plus 5, or in other words, a positive 5. We've got a plus 14, or in other words, a positive 14. And we have a minus h, or in other words, a negative h. Okay? So if we think of those as each as its own thing, it makes it a little bit easier to get rid of the 14 right away. So I'm trying to get this h all by itself. I have two things I need to get rid of, the 14 and this little negative sign. So we'll talk about how to get rid of the negative. But first, let's get rid of that 8 or that 14. So what I'm going to do, since it's a positive 14, I'm going to subtract it. So think this is positive, this is negative. A positive and a negative will cancel each other out. Now I have negative h still on the right-hand side. On the left-hand side, I have negative 9. Now, if we're just thinking logically and we want to get a positive h, we can say, well, if a negative h is negative 9, a positive h must be positive 9, okay? And that is actually true, okay? But let's think mathematically. So what did we do there? We just took the opposite of h, so we took the opposite of everything on the other side as well. That works to think in terms of opposites, but what are we actually doing mathematically? Mathematically, we are multiplying or dividing by a negative. So remember how I said h is like 1h, you don't have to put the 1 there. So negative h is kind of like negative 1h. You just don't have to put the 1 there. So if we pretended the 1 was there, we could get rid of that negative 1 by dividing by negative 1. We could do the same thing on this other side, and negative 9 divided by negative 1 is a positive 9. Also, negative h, 1h divided by negative 1 is just h. So that's why this all makes sense. What are we doing? We're taking the opposite of h and the opposite of 9, and it works. All right, moving on to the next one. I'm just going to divide both sides by negative 2, because when a number and a variable touch, that means multiplication. So to get rid of multiply times negative 2, I'm going to divide by negative 2. That cancels those out. I have m on the left-hand side, and I have negative 10 on the right-hand side. Again, for all of these, you can plug that number back in. So negative 2, lost my pen here. Negative 2 times negative 10 equals positive 20. Check. I'm not going to check every single one because of how time-consuming it is, but you certainly should check them on your test because you'll have plenty of time to do that. Okay, the next one looks like a fraction. It is a fraction, but we know all fractions are also division problems. So n divided by 4 or n fourths. Okay, what makes more sense right now? n divided by 4, because we know the opposite of divided by 4 is times 4. What I do to one side, I will do the same thing to the other side. When I have opposite operations, they cancel out, and I have n left. On the right-hand side, 3 times 4 is 12. And the last one on this page, it's a fraction. We haven't seen a lot of this before. We have seen it, but not often. Two ways you can think of this. If we want to get rid of a fraction, we can multiply by its reciprocal. But what is that really doing? Right now it's saying 2/3 is being multiplied times y. So we want to divide by 2/3. Okay? If I'm dividing by 2/3, think dividing, when we divide fractions, dividing fractions is easy as pie. Flip the second and multiply. So this is my first thing. Flip that second thing, 3/2, and multiply. Now, I'm not super concerned about you remembering how to divide fractions for this because you are allowed to use your calculator. So if you get a fraction problem on the test, you can actually just plug 8 divided by 2/3 into your calculator. If you need help doing fractions on your calculator, come see me before school and I will show you how to do that. Okay, so these will cancel out and I have y. On the other side, I'm going to take my top times my top, 24, and my bot times my bot, 2. 24 divided by 2 is 12. The next learning target, two-step equations. When you have two steps, almost always it's going to be a multiplication or division part and an addition or a subtraction part. So I'm going to do the opposite of both of those, but in backwards order of operations order. So that means first I will undo the addition or subtraction, then I will undo the multiplication or division. Two-step equations need to be mastered, one step as well, because everything builds off of these. Okay, so the first one, I'm going to get rid of the plus 8 by subtracting 8. What I do to one side, I do to the other side. So I have 6x on the left, and on the right, I have 42. Next, I'm going to divide by 6, and x equals 7. I can plug that in. 6 times 7 is 42, plus 8 is 50. It checks out. Next problem. I'm going to undo my subtracting 5 by adding 5. What I do to one side, I do the same thing to the other side. The opposites cancel out. I have 2n is equal to 16. Now I have 2 times n, so I want to divide by 2 on both sides. Opposites cancel. 16 divided by 2 is 8. This looks like I have a fraction in this next problem. And I do, or you can think of it as a division problem. So I'm going to do the opposite of adding and subtracting first. So I'm going to add 7 to both sides. I have x divided by 2 is equal to 16. The opposite of saying divided by 2 is multiply or times 2. Do it to both sides, and x equals 32. And the last problem, the variable is on the right-hand side. That doesn't change anything except for that our answer is going to be a number equals c instead of c equals a number. So I'm going to go ahead and subtract 8 from both sides. I have 3 is equal to c divided by -5 because those canceled. The opposite of divided by -5 is times -5. Times -5. Those are opposites, so they cancel, and I have c on the right-hand side. On the left-hand side, I have -15. Multi-step equations. This means 3 or more steps. For multi-step equations, sometimes we'll be combining like terms on the same side of the equation and then finishing it off with a 1 or 2 step equation. Maybe we are having variables on both sides of the equation, or maybe we need to distribute before we start. The first thing we want to look for is if the distributive property is in this problem. Now, the last section of the test will all be distributive property questions, and I'm going to go over those. This section that we're talking about right now won't have them, but it's still a good idea to look for them because that's what you should do first. I do not see any distributive property. Remember, the distributive property is when there's a number in front of an expression like this, and we have to multiply it out before we begin. So let's go ahead and do this first one. I notice on this first one that I have like terms. Before I begin, I'm going to put those like terms together so I only have one set of x's. So I have negative 7x, negative 5x. Together, I have negative 12x. And this plus 8 could not be combined with that because they're not like terms. On the right-hand side, I didn't do anything with that yet, so I'm just going to rewrite it. All right, now I have a two-step equation. Most of the time, you'll have 3 total steps when they're multi-step equations. So I did one thing. Now I'm down to a 2-step equation. I'm going to subtract the 8 from both sides. I have negative 12x is equal to negative 24. Okay, now I'm down to a 1-step equation. I'm going to divide by negative 12. And x equals positive 2. Again, I can plug this 2 in and say negative 7 times 2 is negative 14. Negative 5 times 2 is negative 10 plus 8. So this is negative 24 plus 8 is negative 16. It checks out. All right, the next one. I don't have like terms on the left-hand side. I don't have like terms on the right-hand side. But I notice I have like terms on opposite sides. So that means I can take one of them and get rid of it, eliminate it, by doing the opposite operation, and that will only show a variable then on one of the two sides. I can do the same thing with these constant terms that I see. So I see a constant term here and a constant term here. We call them constants when they don't have variables with them. Basically, numbers without variables are like terms that just don't have variables. They can be combined together. So it doesn't matter where I start, but in class, I always got rid of one of my variables first. I could get rid of one of my 9s first. It doesn't actually matter which order you choose. So I'm going to get rid of my negative 4x. I'm doing that because I don't like negative numbers. So I'm going to get rid of it by adding 4x. What I do to one side, I do to the other side. Now I like to put it right underneath my 2x because those are the ones I'm combining. I can't combine it with this minus 9 because it's not a like term. I can only put it together with things that are alike. So these cancel out and I have a positive 9. So see, it's a positive 9 left. On the right-hand side, I have 6x now minus 9. I'm going to add 9 to both sides. I have 18 is equal to 6x. Divide by 6, and x equals 3. Plug that in, and I can check to make sure that it's the same. So if I take, say x is 3, it's negative 4 times 3, which is negative 12 plus 9. Negative 12 plus 9 is negative 3. Let's do it on the right-hand side. 2 times 3 is 6 minus 9. 6 take away 9 is a negative 3. If I get a negative 3 on the left, is that equal to a negative 3 on the right? It is. I am correct. Okay. These are just a couple more examples of the same thing we just did, just so that we fully get it here. So I'm going to go ahead and subtract 4 x's from both sides. I'm running into my tools here, so it's going to look a little off, but I've got x on the left minus 7, and on the right, after those cancel, I have a positive 3. If it's a positive 3, I'm just going to write it as 3. Okay? Then I'm going to add 7 to both sides, and x is 10. On the right-hand side, I'm going to get rid of this minus 3m because I do not like those negatives. So add 3m to both sides. Sometimes you can't get rid of all the negatives, but I try. Okay, so those cancel out, and I have a positive 14 on the left-hand side. On the right-hand side, I have 8 times m plus 38. Subtract that 38 away from that m. Those cancel out. On the right-hand side, I have 24. Just double checking, sorry, negative 24 is equal to 8 times m. To get rid of the 8, I'm going to divide by 8. And so now I have just m is equal to negative 3. All right. And a couple more. So this one I'm going to, I noticed that I'd like to get rid of the 3x, but I can't leave it alone. Like I can't leave nothing on the left or the right-hand side because that would be 0, and things just get a little complicated when I do that. So I'm not going to do that. Instead, I'm going to subtract my 5x. Oops, I'm running into my tools again. Subtract that 5x. Let's see. Sorry, technical difficulties. I keep running into my tool bank. Okay, so let's see if I can get technical. Minus 5x. Minus 5x. Okay, so on this side, those cancel out, and I have a positive 2. On the right-hand side, I have a negative 2x. Okay, I'm going to divide both sides by negative 2. And a positive 2 divided by a negative 2 is a negative 1. X equals negative 1. All right, the last one like this type. Big numbers here. I want to get just one p, so I'm going to subtract this p. Now remember, if there's no number here, it's 1. There's one of them. Because if there was 0, it shouldn't show up in the problem. So if I'm subtracting 1 off of here, I'm down to 22p plus 57 is equal to 984. All right, so now I'm going to subtract 57 from both sides. And 22p is equal to, borrow a little bit here, 927. Oh my goodness, why do I do this to myself? So now I've got 927 divided by 22, so that's 488. Subtract and borrow, and I've got 47. This one's going to turn out to be an ugly problem here. So I've got 244, and I've got a remainder of 3. So I've got, I divided by 22, and P is equal to 42 and 3/22, or we could just leave it, honestly, as 927 20-seconds, because that's just as ugly. On your test, you're not going to have any that turn out to be terribly ugly like that. If you do have any fractions, it'll probably end with either be a half, something over 2, or something over 3, or something over 4. If you're getting something over 22, you might want to double check that one. This one was an oopsie. All right. Now the last section, we have some distributive property. So I'm going to take this 2 and distribute it before I begin the problem. So 2 times g and 2 times negative 4. So 2 times g is 2g, and 2 times negative 4 is negative 8. The 6 on the right-hand side gets to stay. I have a two-step equation. I'm just going to add 8 to both sides. I have 2g is equal to 14. Divide by 2. And g equals 7. Next one. This one's tricky. Do you notice that there's parentheses, but there's no number here? So if this were a plus, I could just get rid of those parentheses because it wouldn't mean anything. But since it's not, we want to look at that minus and apply a pretend little 1 there. If this were a minus 1, I could distribute that to each thing inside. Okay, so basically I want to take that negative or that minus and I want to apply it to both. Just like last chapter when we were adding and subtracting polynomials, we were applying the minus to both of the things inside of the parenthesis. That's what we're doing for this too, but I want you to kind of pretend like there's a negative 1 there. So I start with this term out front, and I'm just going to keep it there because it's not affected by what comes after it. So now I'm going to take the negative 1 and multiply it times 5, so I get negative 5. And negative 1 times negative 2x, which gives me a positive 2x. That's equal to x minus 21. Now this problem has it all. So we had the distributive property. Now I notice that they also have like terms on the same side. So I'm going to put those together. 5x minus 5. I could have also written that as minus 5 plus 5x. Just remember you keep whatever the sign is right in front of that term. Okay, is equal to x minus 21. Now look at this. We've got x's on the left side. We've got x's on the right side. We've got constants on the left side. We've got constants on the right side. It doesn't matter which one we get rid of first, but we can't have all that on both sides. So I'm going to subtract x. Remember, x means 1x. So 5x minus an x is 4x minus 5 is equal to, now see this had a negative in front of it or a minus, so we're going to call it negative 21. Don't forget to keep those signs there. It's really important. Now I'm down to a two-step equation, so I'm going to get rid of my plus or minus by adding 5. 4x is equal to negative 16. Divide by 4. And x equals negative 4. A couple more of these problems. This one has distributive property on both sides. So I've got 2 times u, 2u, and 2 times negative 3, negative 6, 3 times u, 3u, and 3 times negative 4, negative 12. Again, I have one of those where I have constants on both sides and I have variables on both sides. So I'm going to combine some like terms, or I'm going to eliminate some variables by saying minus 2u. Now you'll notice that I either take the negative and I make it positive, or I take the smaller variable and get rid of it. It's easier for me to do that because I'm not using negative numbers. Like I said before, you can do these in any order you want. Just sometimes you'll get prettier numbers than others. So sometimes you can kind of plan ahead. So when I planned ahead here, I end up with u minus 12 is equal to, on this side, negative 6. See that? Negative 6. Okay. Now I'm going to add 12 to both sides. Negative 6 plus 12 is a positive 6. These cancel, and I have u. I can plug those back into the equation and check to make sure that they're both equal. All right, the last problem of this video. I'm going to multiply 2 times 4, which is 8. 2 times 4m is 8m. 2 times 1 is 2. It's positive, so I'll write plus. 3 times 2 is 6m. 3 times 4 is 12. I have variables on both sides. I have constants on both sides. I'm going to get rid of my 6m m first because I will not have any negative numbers when I do that. So cross that off. And on this side, when I've subtracted 6m, I have 2m plus 2. On the other side, I have plus 12, which is just a positive 12. I'm down to a two-step equation, so I'm going to undo the addition by subtracting 2. 2m is equal to 10. Divide both sides by 2. M equals 5. All right, just a reminder that I do expect you to show your work on these problems. Your work might not show in as many full-on steps as mine shows, but it needs to show a significant amount of your understanding. If it's a multi-step equation, I should see 3 things happening or more than 3 things happening. If it's a 2-step equation, I should see 2 things happening. And a 1-step equation, I should see the 1 thing happening so that I can see if you're not getting these right, what did you do that was incorrect. Good luck studying. Remember, you can always go to IXL. I've assigned or suggested the skills that will be on this test so you can get a lot of good practice. It's another good place for videos. Thanks for watching.